Hi everyone, welcome to my YouTube channel TechDataEngineer. So in this video, I am going to cover few frequently asked Kafka questions, which will help to understand the Kafka in better way. Okay, so let us start with the first question. Like what is Kafka? What are the primary use cases? Okay, so Kafka is nothing but it is a open source distributed event streaming platform. Okay, so what do you mean? Basically, it is a something like masses like producer consumer services. Okay, how we have a rabbit queue and all in old system queue system. Like some source will send the data to some platform or some storage. You can area storage area staging area you can say, and then from a staging area we will pick the product. So similar to that, this is the concept we have in Kafka also. We have like a producer, we have broker services, storage services, and then we have the consumer services. So Kafka is nothing but it is a distributed event streaming platform used to build real-time data pipeline and a streaming application. Okay, so Kafka was originally developed by LinkedIn. Now it's a part of Apache Software Foundation as a open source. Okay, so what Kafka does basically? So Kafka allow you to publish, subscribe to and store and process a stream of record. So a stream of record is nothing but like a message. Okay. So it designed for why Kafka came into picture because it has high throughput, low latency, fault tolerance, and scalability. So how Kafka achieved how high throughput, low latency, fault tolerance, and scalability? We will see in the upcoming questions. But for now, we can understand that Kafka is nothing but is a like public subscribe service, publish subscribe. So data is getting published and then getting subscribed from some users. Okay, and it is basically to process this stream of record in real time. Okay. Now let us understand with the certain use cases of Apache Kafka. First we have real-time data streaming. Okay, so if you have real-time data streaming, like stream data from the various source like database, logs, IoT device, IoT sensors or applications. Okay, so we have Netflix which uses Kafka to stream log for applications. Okay, in real time. Okay, or log aggregations if we have. So log aggregation is like collect log from the multiple service system and central locations. We have the event sourcing like a store. We have the we will store all changes to application state as a sequence of event, and will take the action based on that. Then we have the data integration like ETL pipeline. Kafka connects different data systems in real time, or we have messaging system or monitoring system like live data monitoring or IoT data sensor like based on the temperature we are maintaining, we are setting up or setting down the like machines. So based on IoT or sensor data or website active tracking like which user is crawling what particular page or what actions is getting triggered on the particular page. So these all are the example of Kafka. Okay, so it is all are the example of Kafka based use cases. Okay, where Kafka comes into picture. Okay, now so in these questions we understand what is Kafka and what are the use cases of Kafka. Okay, we can explain like that. Then the second question is explain the core concepts of Kafka broker. What is Kafka broker? What is topic? What is partitions, producer and consumer many more. Okay. So let us start with the broker. So Kafka broker is nothing but it is like a server. Okay. So as we know that in Kafka we have producer services, then we have broker service, then consumer service. Like produce to the produce to the storage area, and then from a storage we will get the consumer consume the data. Okay, so let us understand in the terms of Kafka. So Kafka is broker is a server that store and manage the message in Kafka. Okay, so what it handles? So receiving data from the producer. So there is a producer called P. it will send data to the storage area, and from a storage area there is a C, consumer consume the data. Okay. So receiving data from the producer, storing data on disk, and serving data to the consumer. So these are the part of the Kafka broker. So Kafka broker is, think it's like a message warehouse, okay, where data is getting stored, producer is producing, and data is getting stored from the data get the stored data is getting consumed by the different consumer. Okay. So a Kafka cluster is made of multiple broker for scalability and fault tolerance. Okay, so we have multiple broker because if one is getting down, so we will achieve fault tolerance with the help of other broker. We can up the other broker. So broker is nothing but it is a server that store and manage the message in Kafka. Okay, so we'll understand that. So what is topic? So topic is a category or feed name to which messages are published. Okay, so we will understand in a layman term. Suppose there are three department. Okay, so there are sales department, finance department, and HR department. So ideally, we should create three topics, like the one for HR, where HR data is getting stored to that HR topics. Finance data is getting stored to the finance topic, and IT data is getting to the IT topic. And the subsequent, if consumer have to consume the data, it will consume from the different domain wise topics. Okay, so topic is nothing but it is a category or feed name to which messages are published. Okay, so producer send message to a topic, consumer read message for a topic. So suppose there is a producer that produce the IT the data to like you can say IT data to the IT topic, and then there is a consumer which will consume data from the IT topic. It can't consume from the sales topic. So for that only we have like different topic for categorizing the different category. Okay, so think it is like a channel where data is written and read. Topics are partitioned for performance. Okay, so we have broker, then we have the topic, and the topics are uh, partitions into different, so divided into, subdivided into the different partitions. Okay, so partitions is nothing but it's like a subdivision of a topic. Okay, so each partitions is an ordered, immutable sequence of messages that continually appended to. Okay. So, we will understand this with the pictorial representations, how there is a topic, what is the partitions, and under partitions, how are the offsets getting calculated. We will see in the next upcoming questions. Okay, so each message in partitions a unique offset, like a number. So there is a data, there is a topic. Each topic is different partitions. Like topic is a T, then it has a P1, P2, P3 partitions. P1 start from 0 to 100, then P2 again start from the different numbers. So each number 0, 1, 2, 3, these all are the offset number. Okay, why offset is required? We will see this also in upcoming questions, like why offset numbering required, how it will maintain the order and all, everything we will see. Okay, so for now we understand that. So partitions is basically subdivision of a topic, and each partitions is order immutable. Okay, and each message in a partition has a unique offset. This we have to remember. So partitions allow Kafka to scale horizontally. Okay, more partitions means more parallelism. So more partitions equals to more. So if there are more partitions, like more producer will produce to the this one, and more consumer will consume from that. Okay, so think partitions as a separate file within a topic that allow parallel reads and parallel write from the different producer and consumer. Okay. So now we understand what is a producer. Okay. So we understand what is partitions. Now coming to producer. So a producer is an applications or service that sends data. So simple term, producer as a name suggests, it is the work is to produce the data to that particular broker or storage area. You can say consider for that. Okay, or message. Okay, so producer is an application or service that sends data to a Kafka topic. Okay, so topic is getting stored to the broker or cluster, and the different broker creates a cluster, Kafka cluster. So producer is an application or service that sends data. I can see, consider the data, event or message to a Kafka topic. Okay, so producer chooses which topic to write, and Kafka produce can be asynchronous and high throughput. Okay, so producer is nothing but it's like a data sender. Okay, now, what is consumer? So, as name suggests, consumer is an application or service that reads data from the Kafka topic. So, consumer is nothing but the work is to consume the data from the Kafka topic. So, there is a topic in middle T. There is a producer is going to produce the event or data, and consumer is going to consume the data. Okay. So, consumer subscribe to a topic and read message from partitions. Okay, so that's why consumer work is to go to a different topic. From topic, how many partitions are there? From that partitions, it's parallelly. You can read the data. That's why parallelism comes into picture, or vertical scaling, horizontal scaling comes into picture. Okay, so they track offset, so they know what message they have to process. Okay, so consumer is nothing but it's like a data reader. So we'll understand by the summary diagram. So there is a producer which is produce the data to the Kafka topic, and each topic has a different partition like zero partition, one, two on broker. So these all are managed by a broker. You can say like a server, and then consumer is work is to consume the data from the partitions under the topic. Okay. So simple term we understand. There is a producer which work is to produce the event or data to a Kafka topic, and that is the Kafka topic partitions is managed under broker. Okay, and broker is a server, and there is a consumer which consumes the data from a partitions under a topic. Okay, so if there are three partitions, three consumer will consume the data parallelly. Might be some consumers, if there is a less partitions or more partitions. So based on the consumer, some consumer get ideals also. We'll see what is consumer group and all. Okay. So producer writes to a topic. Topic is split into partitions. Partitions are stored on broker. Okay. And consumer reads the message from partitions. Okay. So this way we understand. Okay. Coming to the next question. What is Kafka topic? How it is different from queue? Okay. So what is Kafka topic and how it is different from the old queue system? Okay. So this question also most of the time they used to ask to understand the differences. Okay. So Kafka topic is named a stream of record masses to which producer sends data and from which consumer reads data. So a topic can move one or more partitions. A topic can have so in a topic can have one or more partitions. So if more partitions means more parallelism. Masses in a topics are ordered within each partition. So each partition's masses are always ordered. So that's why it is always the guarantee giving the ordered data. Okay. So data is retained for a configuration period. Okay. So we have the options to configure the retention policy, data loss after reading the consumer, how many times they can till what times we have the retention policy, like data will not be lost. But this was not the case in case of Kafka. Earlier our old queue system. So once the consumer consume the data is getting lost. You can't retain the data. So that was the disadvantage with that. So we will see the differences also. So topic is a log file that can be read independently by the multiple consumer. Okay. And now we will see the difference between a traditional queue and Kafka topic. So if you'll see the consumer model, so publish service, so multiple consumer can independently read the same message, but here point to contact each message is delivered to only one consumer. So that was the different, like a rabbit QMQ, active MQ. Then message retention, so messages are retained for a fixed time regardless of consumption. And in case of earlier old system like rabbit MQ and active MQ, messages are removed once consumed. Okay. So, if you'll say replayability, so consumer can reread message by offset. Okay, here no replay. Once consumed, message gone. Okay, so these are the difference. Then we can scale horizontally Kafka topic by partitions. Traditional queue, rabbit queue or MQ harder to scale for large workload. Order is guarantee within a partitions. This was guaranteed through the partitions Kafka, but here usually strict ordering per queue. Okay, multiple consumer can read in parallel in case of Kafka, but typically only one consumer receive each message. So best for stream processing, analytics, and event sourcing. Best for task queue or job processing. So if there is job processing we have to do, rabbit queue is best use case. Okay, best fitted. So understand Kafka topic like a new broadcast. Broadcast means it is broadcasting to the multiple consumer. And queue is like a phone call. If it is getting disconnected, its person is not able to connect to each other. Okay, so that was the difference in that. Now moving to the next questions. What is partitions and in Kafka and why it is important? Okay, so what is partitions is Kafka? So partitions is a subdivision of Kafka topic. So as we already understand, like so we have a broker. Under broker we have broker is a server area where we have the topic is based on the different domain, like sales we have different topics, IT we have different topic, finance we have different topic, and each topic can have one or more partitions. Okay, so partitions is order immutable of a message. Every message in a partition has a unique offset. Okay, so each partition each an order or immutable log of message. Okay, so topic is divided into different partitions, and partitions are distributed across Kafka brokers. Okay, so why partitions are important under the Kafka topic? So first is the scalability. So Kafka can handle massive amount of data because of partitions can be spread across multiple broker. So if there is a multiple consumer, is more partitions means more parallelism. Like more consumer are there to consume the data, more producer are there to produce the data. So there is a scalability. You can scale. ठीक है. And other thing is parallelism and throughput. So producer can write to partitions in parallel. Okay, so there is a throughput also. Like we can give the maximum efficiency. Okay, so consumer in a group can read from the different partitions at the same time, increasing the throughput. Okay, so different partitions at the same time. So if we have a consumer group like C1, C2, C3, C4, so there is a different consumer. Okay, so multiple. So in a suppose there is a consumer group. We have four consumers: C1, C2, C3, C4. So it can read from the different partitions also to increase the throughput. Okay. Then ordering guarantee. So Kafka guarantee masses order within a single partitions, not across partitions, but under the single partition there is a masses guarantee. Okay, so this is important if your application's log depends on the strict ordering. Okay, then fault tolerance. So Kafka replicates partitions across broker. Okay, so because of the this replication partitions, if one broker fails, another broker with replica can take over. Okay, then we have the load balancing feature also. Okay, so in a consumer group, like each consumer can handle one or more partitions. So this enable distributed processing. So we will see with the different example. So there is a say you have a user event, and we have so there is a topic user event which have the partitions p0, p1, p2. There is a three partitions. There is a topic. Okay, so producer is writing data to the Kafka and around Novi manner. Okay, so there is a consumer group like consumer one, consumer two. So one reads data from P0 partitions, consumer two reads from P1, and consumer three reads from the P2. Okay, so each partitions can be processed independently, making Kafka fast and scalable. So this way basically our Kafka works. Okay. Now coming to the next questions. What is Kafka consumer group and how does it work? Okay. So Kafka consumer group is a way to coordinate multiple consumer. So this is the consumer group. Suppose we have consumer one, consumer two, consumer three. These are the called consumer group. So consumer group is a way to coordinate multiple consumer that are reading from the same topic so they can share the workload efficiently. Okay. So under a consumer group, if there are multiple consumer, they are reading the data from the same topic. So so that they can share the workload efficiently. Okay. So what is consumer group? So consumer group is a set of consumer. So there is a consumer group C1, C2, C3. Like there is a consumer one, consumer two, consumer. So these are called consumer group. It is a set of consumer that work together to consume masses from a Kafka topic in parallel. Okay, with each partition as assigned to only one consumer. So each partition, like partition number 0 is assigned to consumer 1, partition 1 is assigned to consumer 2. Okay, so assigned to only one customer in the group at a time. So at a time, it can only read one partitions. So each consumer group has a unique group ID. So how it works basically? So Kafka ensure each partitions is consumed by only one consumer within a group. Okay, but different consumer group, like there is a consumer group, if they have the different ID, they can independently read the same topic. Okay, you can set up like that. So that if consumer joins or leave this group, Kafka rebalance the partition assignment automatically. Okay. So now we'll see with the example. So assume we have the topic order with three partitions, P0, P1, P2. Okay. So scenario first we will see. So consume, so one consumer in the group. Okay. So consumer group. So there is a group A. So one consumer, so reads P0, P1, P2, three partitions. So if there is a scenario two, we have the three consumer in a group. Like consumer one reading the P0 partitions, consumer two reading P1 partitions, and consumer three is reading P2 partitions. There is a four scenario where there are scenario three, there are four consumer in the group. Okay, so and more consumer than partitions. So if that scenario will happen, what will happen? Consumer one will read the P naught, consumer TP1, consumer three P2. If there is a more consumer group, there is a more consumer in a group and no partitions, then it is sitting idle. Okay, that Kafka does not split partitions among consumers. Okay, so among consumer it does not split. Okay, it assign whole partitions to a consumer. Okay, so why, what is the benefit of consumer group? It is basically used for parallel processing, fault tolerance, independent consumptions. Okay, so we will see here, we will see the consumer group versus single. So this PPT is itself self-explanatory. This is written in such a way that you can, after reading only, if you have the basic idea about Kafka, you will understand the questions and explanation. Okay. So coming to the next topic, how does Kafka ensure message durability and fault tolerance? Okay, so Apache Kafka ensure message durability and fault tolerance through a combination of a replication factor, commit log, acknowledgement protocol. Okay, so message durability means like Kafka guarantee that message will not be lost once they are acknowledged, even in the case of failure also. Okay. So how it ensure durability? So for that we have the commit log, like each partitions is append only log stored in the disk. Messages are written in the log before acknowledged to the producer. Then we have the configuration retention. So Kafka store messages for a defined time period, like 7 days or 10 days, regardless of whether they are consumed or not. Okay, so these are the benefits in case of Kafka, which was not benefit in case of earlier our queue system. Then we have the acknowledge policies also. Acknowledge zero means producer does not wait for acknowledgement for uh, so in case of acknowledge zero, so acknowledge one means Kafka acknowledge after the leader broker gets message. If acknowledge all means Kafka acknowledge only after replica get the message, like most durable cases. So which scenario we are using what acknowledgement policies? Then we have the Kafka, sorry, fault tolerance. So Kafka designed to tolerate broker failure and consumer crashes and even network partitions. So we have the replication factor, like each partition is a leader and follower replications. So that set the replication factor, leader follower model, or in ISR model. So these are the mechanism. Basically, it will use to help the fault tolerance, like zookeeper or Kraft metadata management. Okay, so basically this uses zookeeper also to keep track of cluster metadata or trigger leader elections when needed. Okay, so Now coming to the next question. So what is Kafka message retention policy and how is it configured? So Kafka message retention policy, as I already explained, we have to set the retention policy even after we are consumer is consuming the data, or if you have said the acknowledged also. Like Kafka message retention policy control how long messages are kept in a topic regardless of whether they have been consumed. Okay, so in case of normal system, normal queue system, once it is getting consumed, data is getting lost. You can't retrieve that. But in Kafka we have the retention policy. uh, Regardless of fact that it is consumed by the consumer, we have to keep that particular message in a topic for certain amount of time. Okay, so this is one of the Kafka key strength compared to traditional message queue system, which deleted the message immediately after consumption. What is Kafka message retention policy? So like Kafka store message in a topic partitions and retain them based on like time, size or long compaction. So retention.ms, retention.bytes. Okay. So keep message for a certain number of milliseconds. So this millisecond it will keep the data to the topic, or keep message until the partitions log reaches to the certain size based on the size factor, or log compaction, like keep only the latest record for each key. Okay, so there are the three way we are maintaining the retention policy. So okay, time-based retention policy like 7 days and all, we have to set up retention.ms or size-based or log-based. Okay, so these are the three way we can set it up. Okay, so that we have to set up like retention policies like from each topic. So while creating the topic like Kafka topic, so while bash command, while setting the configuration, you can set up the config.retention ms equals to this much of millisecond. Okay, while setting the verb, or in existing topic also you can set like retention ms equals to 300 double zero triple zero millisecond. Okay, so this way we can set up the retention policy. Now we'll see next questions. What are offset in Kafka and how they are managed? Okay, so in Kafka, offset are so tip critical to keeping track of which masses have been consumed. Okay, so offset, so we understand that there is a topic is shown on the broker. So there is a topic is topic, so topic is divided into multiple partitions. So under each partitions we have the numbering like id assigned to each particular message within a partitions. Okay, so we'll see with the example. Suppose you have a partition 0. So partitions 0 have offset like 0, 1, 2, 3, 4. For message A, we have the offset 0. For B, we have 1. C, we have 2. D, we have 3. So consumer has processed up to 2 offset. So it know you have to start from the offset 3. So based on the configuration again, we if we have set like latest or we earliest. So based on the Kafka consumer setting or reading policies, we will set up the we will this offset will help to retrieve the data. Okay, so how offset are managed? So manually by the consumer, like consumer reads a message, process it and commit the offset, or automatically by Kafka client also, like the client can configure to the commit offset automatically at interval. Okay, so enable auto commit equals true means like based on certain millisecond every 5 second it is doing that. Okay, so where are offset stored? So offset Kafka store committed offset in a special internal topic called consumer offset. Or in case of Python PySpark, you can use your own storage area also to store the topics, especially topic. Okay. So this enable fault tolerance for state recovery. We know that offset is stored for consumer group and per partitions. Okay. So offset like position of a message in a partition. Committed offset like last offset consumed. Okay. So what is committed offset? What are the last consumer consumed that offset? Auto commit like Kafka commit offset periodically. Okay. Manual commit application commits offset manually. Okay. So why offset matter? Like they allow message reprocations. Okay, go back to the old offset or enable at least one or exactly one deliver guarantee. And Kafka help to letting consumer track their own progress. Okay, so this way, that's why we are using the Kafka offset. Okay. Okay. So these are the questions which we covered in upcoming video. We will cover more advanced level questions. Okay. So thank you. Thanks for watching.